Okay, so this says we measured 23, hold on, let me see. 23 watermelons weights and find they have a mean weight of 60 ounces. Assume that the population standard deviation is 14.1 ounces. Based on this, what is the maximal margin of error? Maximum margin of error associated with the 95% confidence interval for the true population mean watermelon weight. Okay, there's actually two ways we could do this. We could do this with the formulas, and we can also do this with the calculator. So I'll show you both. So a confidence interval for the population mean, when sigma is known, is given by the following, the two equations here. So this is a compound inequality, but the true population mean is between the lower bound we get from the sample mean minus our margin of error to the sample mean plus the margin of error, where the margin of error is defined by this. So basically, we're going to be using this thing to figure out what the margin of error is. So our margin of error is just going to be equal to the z value associated with the 95% confidence interval. So this would be the z of, so in this case, alpha is 5%. So this would be 0.025. It would be the z value that cuts off the bottom 0.025 of the graph. Times the population standard deviation, which is 14.1, over the square root of n, which is 23. So I can find this z value by using the distributions menu, going to inverse normal. The area, so I'm going to assume you don't have this option here, left, center, right. If you do, that doesn't really change anything. But the area I'm looking for, the area is to the left of that value. So if I were to draw a quick normal curve, I'm looking for the z value that cuts off, positive z, that cuts off the middle 95% or 0.95. So this is 0.025, and this is 0.025. 2.5%, 2.5%. So you can use either one. I'm going to use this one and then just forget about the negative. You could either plug in 0.975 or 0.025. Mu is 0, sigma is 1. So my z value is going to be 1.95996. Times 14.1 divided by the square root of 23. So it's just going to be this times this, and I'm dropping the negative. So my margin of error is going to be 5.7624. Another way you could do this is you could actually just calculate the confidence interval in the calculator. If you hit stat, go to tests, we're doing a z interval. Just scroll down there to z interval. I'm going to input stat. So the population standard deviation is 14.1. X bar is 60. My sample size is 23, and I want a confidence level of 0.95. If I calculate that, I get my bounds, right? But this formula here basically tells me the upper bound of my interval is just the sample mean plus the margin of error. So this number here, 65.762, is the sample mean minus the margin of error. So if I just do 65.762 and subtract the sample mean, which was 60, I get my margin of error, which is 5.762. Okay? The bounds of your interval are just the margin of error plus or minus that value. So you really could use either one.